Okay, look, what we're going to learn to do right now is how to make a regression line and interpret it using Microsoft Excel. What you can see here is I have a set of data. I have the GPAs, PSATs, ACT, and SAT scores of a number of students. So like I said, we're going to learn how to make a regression line, and a regression line is basically just a straight line that describes how a response variable, the y value, changes as the explanatory variable x changes. So basically, as the values along the x-axis change, we want to be able to predict what the y values are going to do. In order to do that on Excel, first we've got to make a scatter plot. So we'll make it one first of ACT and SAT scores, and I'll just highlight the first 20-some students. Go to Insert, Scatter, and immediately we get a quick scatter plot right here. We have along the x-axis the ACT scores, and along the y-axis the SAT scores of these students. Now we want to insert a regression line for this, and basically all you have to do is right click on any one of these data and you go to Add Trend Line, and then at the bottom it will say Display Equation on Charts. We'll also click on the Display the R-square value on chart. And you close and it will pop up. You just got to move it so you can see it. And here we have an equation, okay, for our regression line. What you should recognize is that this is the slope-intercept equation from an Algebra 1 course. You have the x here, you have the slope right here, and you have the y-intercept right here. So if you were to extend this line down here, it would intercept somewhere around 656.35. Now what this equation allows us to do is we can plug in any x value, and remember x values in this case are the ACT scores. If we plug in an x value, we can get out a y value, meaning an SAT score. So if we want to be able to predict an SAT score, we can plug in an ACT score into this equation. So simply, if we try it out real quick, we can do 43.831 times an ACT score of 20 plus 656.35 and enter. And basically what we're saying is, based on this equation, if a student has an ACT score of 20, that their SAT score would be a 1532. Now keep in mind, this all depends. You cannot just make a correlation and assume it to be true or correct unless you analyze the R value and analyze the strength of the correlation. However, the regression equation allows us to predict y values based on x values. Now the most important feature for us to understand about the regression line equation that we have is the slope, because the slope basically allows us to see what the overall pattern is of the regression line. In our case, we have a slope of 43.831, but if you can recall from an Algebra 1 course or any other course, slope is rise over run. So what we have is 43.831 over 1. That is a rise over a run. And if we think about it with what we're looking at right here with regards to this data, our rise is our SAT scores, our run is the ACT scores. And what we're saying, and what this slope is saying, that as an ACT score increases by 1 point, the SAT score increases by nearly 44 points. That's the overall pattern and trend of this regression line. As ACT goes up 1, our SAT scores we predict would go up 44 points. Now most textbooks are going to refer to the regression line that Microsoft Excel or other programs create as the least squares regression line. And basically, it's a method by which to generate the regression line. We're not going to get into the actual equation in this right now of how it actually works, but basically the idea is that the line that is drawn by Excel through all of our data is a line that has that makes the sum of the squares of the vertical distance of the data points from the line as small as possible. Now, what that means is kind of complicated. We'll look at this other image right here. Here we have another set of data. We have body weight along the x-axis, and we have the pack weight, basically a backpack that someone would be carrying. And they're trying to analyze the correlation between, as a person gets heavier, how much weight they can carry in a backpack. You can see already that they have all the data points, these dots, and they've drawn a regression line. And this regression line is a least squares regression line. Now, what you should also notice is in bold there are these vertical lines that are the distances from the data points to the regression line. Now, what Excel is trying to do in any other program, if they're using a least squares regression line method to draw the regression line, is that they're trying to minimize the vertical distance from the data point to the line so that the line will fit straight through all of these points with the least amount of vertical distance between all of those points.